Spanning tree protocol will go through a four-step process to ultimately determine which port or ports within the topology are in the blocking state. In order to identify these ports, it has to firstly identify the root bridge within the spanning tree topology. It will have to identify the root ports within the topology, and then the designated ports within the topology. Once it determines these three items, it can then establish which of those ports are blocking or are the non-designated ports. And it's these non-designated ports that are ensuring that the loop no longer exists within the topology. So how is all of this accomplished? It's accomplished through the exchange of Bridge Protocol Data Units, BPDUs for short. And these BPDUs are exchanged every 2 seconds by default within the spanning tree topology. So the BPDUs are carrying the information that spanning tree protocol needs to ultimately determine the spanning tree topology. So before we even look at this information that's in the BPDU, what about the frame itself? It's a layer 2 frame that's being sent with this information. Well, there's a source MAC address, and that source MAC address is going to be the MAC address of the sending interface. So if this switch is sending a BPDU that way, well then, that is the source MAC address. It's the source MAC address of that interface, right there. What if a BPDU is being sent this way? Well, the source of the BPDU is this interface right there, so the MAC address of that interface. But what about the destination MAC address? Who is it going to? Well, there's a special multicast MAC address that's reserved for spanning tree protocol. And that multicast MAC address is 0180 C200 0000. That's the spanning tree protocol multicast MAC address. And it will be used for the destination of all spanning tree protocol BPDUs. When we examine now the data that's carried in the BPDU, we can see a protocol ID indicating that this is for spanning tree protocol. We can see the version of spanning tree protocol that this particular BPDU is associated with it. We can see the message type. Is it a configuration BPDU? So is it utilized for calculating the overall spanning tree topology? Or is it a topology change notification BPDU, which is going to be utilized to inform the other switches in the topology about changes that have occurred? And if this is a topology change notification BPDU, there will be certain flags set within the BPDU to give a little more information as to what really is going on with these topology changes. As we move down, we'll see the root bridge ID. Now, this is really important because all the switches need to agree upon who the root bridge is within the topology. So what will happen is that all the switches that have determined who the current root bridge is, they will include the root bridge ID in the BPDUs they send out. So as this particular switch here is sending out a BPDU down to the switch over here, it's going to indicate who the current root bridge is. So if it is the current root bridge, it'll include its root bridge ID. If it's this switch over here, then it includes that switch's root bridge ID within this BPDU that it's sending. In addition, there'll be a root path cost that is listed as well. And this root path cost is going to be utilized during the decision-making process to determine what is the optimal path in order to reach that particular root bridge. So when we look at this topology, let's pretend this switch here is the root bridge. Well, if this particular switch is the root bridge, then as this switch advertises its BPDU this way, it has to tell this switch how far away the root bridge is from itself. So let me assign some arbitrary costs here to this topology. Let's say this is a cost of 2, this is a cost of 10, and this happens to be a cost of 2. Well, in this case, this switch here, when it advertises or sends a BPDU to this switch, it says I am 2 away. So now when this switch performs its calculation, it says, well, then I must be 10 plus 2 away from the root bridge for a total of 12. And as a result, when it sends its BPDU this way to this switch, it is advertising a path cost to the root bridge as 12. So now this switch sees itself as 12 plus 2 away from the overall root bridge. So it's this cumulative calculation that is needed in order to ultimately determine the optimal paths through the spanning tree topology, which is known as the root path cost. So that will be advertised throughout the layer 2 topology so all the switches can make their decisions. The sender bridge ID, so who is sending this particular BPDU? So not only is the root bridge's ID included in the topology, in the BPDU, but as this switch sends the BPDU, it's also going to include its own bridge ID along with the root bridge ID. And that way there, the other switches know who's who and where they are within the topology. Looking further down, we also see this port ID listed. What is this port ID? Well, every single port that is used in a spanning tree topology will have an identifier. And that identifier is a value which defaults to 128 dot something. And that something is a number associated with the interface by the switch itself. So, for example, fast Ethernet 0/1 might be 128.1. Fast Ethernet 0/2 might be 128.2. Gigabit Ethernet 1/0 might be 128.25 if it's on a 24-port switch with 24 fast Ethernet ports before. So the number you see here is going to be assigned by the device, and this is just a default value that's utilized with the port ID, and you can modify this port ID. And it's going to be one of those values that are used during the decision-making process to determine what is the best path to use with spanning tree for spanning tree protocol from the various devices. You'll also see a message age. So how old is this particular message? You'll see a maximum age. So what is the maximum age for a BPDU? By default, the maximum age is 20 seconds. 20 seconds, a value you will want to remember forever. That's the default maximum age. There's the hello timer. Does anybody remember what I said? Was it hello time? How often a BPDU is sent? Remember? 2 seconds by default. So 2 seconds. So you can change that, but it's 2 seconds by default. And then there's this forward delay timer that's going to be utilized during the convergence period of spanning tree protocol, during the transitionary phases when topologies when the topology is being modified or changed because a port has gone up or down, or new interfaces have been added, or new links. While the forward delay is 15 seconds by default. So these timers are advertised within the BPDU because all of the switches in the topology have to use the same timers, which are advertised by, take a wild guess who it is. If you said the root bridge, you are correct. So everybody's going to use the same timers that the root bridge is telling them to use.